Okay, so here we were reading the last problem. We have that the time required to load and unload the parts is 12 minutes, and the cost of machine time on this boring mill is $40 per hour. Management has decreed that the production rate must be increased by 25%. Is this possible? Assume that feed must remain unchanged in order to achieve the required surface finish. What is the current production rate, and is the maximum possible production rate for this job? So what we want to find here, we should see if it's possible to increase by 25% the production. Okay. In order to do so, first we should compute what is the actual production rate and see what is the maximum production rate that can be done. And then we can see if this maximum is by how much higher than the actual rate. So we need to have a rate, we need to increase the rate by 25%. So if this increase is smaller than the maximum capacity, then we can do it. If not, we can't. Okay, so this is why the first step is to assess what is the actual production rate in order to compare it with the maximum production rate. So to do so, I should first start by calculating what is the actual rate of production. To calculate the actual rate of production, I can just compute what is the total time needed for production of one piece. Once you get this time, okay, you can divide then 60, which is for 1 hour, you have 60 minutes. Okay, so if you can calculate the time required per piece, all you have to do is for 1 hour to divide 60 by T total to produce one piece, you get the rate in piece per hour. Or if you just want piece per minute, you just do 1 over this value. Okay, but in order to get a value higher than 1, because we are talking about number of pieces, then we can calculate here they calculated in piece per hour. Okay, so first, since it's a boring operation, so we will use its parameter. They gave us the cutting speed, and they gave us the values of C and N. So from C and N, we can compute the tool life by doing C over V to the power 1 over N. We get the value of T. Now, once we get T, we should find the machining time in order to get the number of pieces per tool life. So here for the machining time, just for a boring mill operation, we just apply the rule. So it's also pi dl over fv. So we have d and l. Now just here pay attention for your units. Why here? So these parameters are, this is v, this is the feed rate, but why we have here 12? This is due to conversion of unit, because as you can see here, the length and diameter are given both in inch, and concerning the depth, it's given in so for the feed, it's in inch per revolution, okay, 0.015, while the speed is in feet per minute. And you know that in case I have the speed in feet and the other parameters in inch, I should convert feet to inch. So due to this conversion, I should multiply the speed by 12. So it will be 200 times 12. This is why here you have 200 times 12 times 0.015. So this is V. And when we multiply by 12, it's just to change its unit from feet per minute to inch per minute. Okay. And then all other measures are in inch. Then the machining time will be computed in minute per piece. Once I get the machining time and I have the tool lifetime, I can get the number of pieces produced, which is the tool life over the machining time per piece. I get then the number of pieces that can be produced during one tool life. Once this is done, I can calculate the value of the total time needed to produce a piece. As usual, we have the handling time, we have the machining time, and we have the tool change time per piece. Since the total tool change time is 3 minutes, and we have 15 pieces produced, so it's CT over the NP, it's 3 over 15. Okay. Now, this is the time needed to produce one piece. So if you want, then the production rate will be 1 over 46.4 pieces per minute, or if we convert to hour, it's 60 over 46.4. So we are able to produce 1.293 piece per hour. Now, what we want to do is to increase by 25% the production without changing the value of feed. So the feed should be maintained the same. We just can change the cutting speed. Okay. So in order to do so, we want to determine what is the maximum possible production rate and compare it with the actual production rate. So in order to calculate the maximum production rate, we will use the formulas of Vmax. So as we have seen before, we have Vmax affected by the value of C, by the value of N, okay, and by the tool change time, which is here 3 minutes. So we can compute the value of Vmax. Once we get Vmax, okay, we can find the corresponding value of Tmax also using the formula, because you have here you have the parameters, okay, for each for minimum and maximum, okay, you have the corresponding values of so Tmax is 1 over n minus 1 tt, so you can calculate the corresponding V and the corresponding T for each case. Okay, so now once we get the value of Tmax, we can compute, in order to compute NP, we should find T machining. So it's the same steps, just now we are working with other values of velocity. So instead of the cutting speed of 200, we have now 500. We can compute the machining time and the corresponding number of pieces. And once we get this, for the total time, we just add the handling time, the machining time, and the time per the tool change per piece, which is T over the number of pieces produced per tool life. So we can get then the total time required for the production of one piece, and from here to calculate the rate of production, the maximum, this is the maximum rate of production, it is equal to 60 over 29.8, 60 because we convert from minute to hour. So this is the number of pieces we can produce per hour. So as you can see, the maximum possible increase in production rate will be 56%, because the maximum percentage of increase is 2.01 minus 1.293. And you divide by, so here nearly the difference will be 0.7, divided by the initial rate, which is 1.293. So you get nearly, it's 56% increase. Okay, so since we want to achieve 25%, so we can do it, because the maximum possible increase is 56. Since 25 is smaller than 56%, then it is possible to do this increase without changing the feed rate. We just have to change the cutting speed. And of course, we don't have to reach 500, because 500 feet per minute will give us an increase of 56%, while we just need an increase of 25%. So if they ask you what should be V to get this increase, what you will do, you can just do it in a backward way. Yani you put here an increase of 25%, you calculate RC, and you can go backward. You can do this by iterations to get what is the speed that will give me this value. Okay? Any question on this? Okay, so we continue next time. Bye-bye.
Doctor?
Yeah?
Can I ask you two small questions in chapter 17?
Yes, sure. Yes.
Doctor, when you ask for the power of the machine, we do the gross power or the power, the FC times V?
It will be specific. Okay, I will tell you. Okay.
Yes, okay. And the angle always are optimum. We can use always the equation of the optimum angles.
Yes, yes, but everything, يعني, everything will be clear in the given. All assumption needed will be stated. Don't worry about it. Okay?
Yes, okay. Thank you.
Welcome. Bye.